Good morning, everyone. I am Pranali, your host for today. I welcome each and everyone for today's Sadgun Sang Meet. This is our 270th virtual webinar. Topic for today is Sustainable Water Management and Plumbing, which shall be taken by Mr. Kondala Rao Gonuguntla Sir. Agenda for the Sadgun Sang Meet, virtual inauguration by Dr. Sundar Kataria, invoking the blessing of Deti chanting of Gayatri Mantra, introduction of speaker, presentation by Mr. Kondala Rao Gonuguntla, question and answer session, closing session. Dr. Sundar Kataria, Chairman and Managing Director, ICS Group Companies. Sadgun Sang conceived and led by Dr. Sundar Kataria, driven with a mission to elevate the quality, safety, and environmental awareness levels of industry. Sadgun Sang is a series of educative, informative events aiming to illuminate professionals on possible solutions to current issues of industry and economy. Designation and organization, Chairman and Managing Director, International Certification Services Private Limited. Academic qualification, Mechanical Engineer in Honorary Doctorate, Business Management. Experience, Nuclear RAP. He started his career in building India's first nuclear power plant at Rawatbhatta, Kota, Rajasthan. Oil and Gas EIL. He contributed in developing India's first oil and gas field at Bombay High since its inception. DNV. He was head of industry and offshore development with DNV for 2 decades. ICS. He is a founder of a first Indian conformity assessment and inspection body known as International Certification Services Private Limited, which is a provider of a total quality solution under single umbrella with a wide spectrum of services. Achievements and awards. Lifetime Achievement Award of NACE Kokon received several national and international awards. Now I request Dr. Sundar Kataria to virtually inaugurate the session.
आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः.
Please join us for the recitation of the Gayatri Mantra. Introduction of the keynote speaker. Designation and organization, ESG and sustainability professional, ESG environmental, social and governance, academic qualification, BTech Civil JNTU Kakinada, ME Structures Osmania University, PG diplomas in Energy Management and Environment Management, University of Hyderabad, area of specialization, urban water supply and sanitation systems, energy efficiency and sustainable urban infrastructure, ESG and sustainable development, WASH and climate action. Welcome you, sir. Over to you, sir.
Thank you very much. I'm sharing my presentation.
You can share your screen.
Yeah. Screen sharing. Is it visible?
Yes, it is visible, sir.
Is it visible?
Yes. Make it
Fine,
full
one.
screen. Slideshow.
So, is it visible?
Yes.
Wonderful, great. So, dear brothers and sisters, good morning and namaskar to all of you and all the viewers. My phone number is also given. Anybody can be in contact with me. I'm your brother here at any time. So we are going to discuss. I thank the ICS Technologies Limited for giving me this opportunity to be sharing with whatever little I know, whatever experience I have got with all of you. You are all distinguished people. So it's a pleasure for me and privilege for me. So we integrated water management and plumbing systems to some extent. So the issue is our water resources and our water quality are a matter of concern for quite some time. So that is the context in which we need to focus more on the water access, that is water availability, and also water quality and overall water management. So that's what we are concerned about. So in water management, it includes stewardship. That means we have to take the responsibility ourselves into our hands. So circularity principle. So in terms of sustainable development goals, the circular economy, the environmental sustainability, financial sustainability, etc., and the resilience against climate change, against disasters, etc., and how the waterways have to be channeled, and how they have to be. We have to ensure that they really go a clean water on a sustainable basis. These are our concerns, and the water security and water safety both are our concerns, and access and quality. So today we'll be discussing integrated water management and outline and the plumbing systems to some extent, and sustainable water management, sustainable drainage systems, and some sort of waste management, and some key takeaways and essentials for success and fulfillment for the young people and the purpose of life as I see it. So uh, can we mean close this the top 1 minute? Hide, yeah. Okay. So now, madam, can we close this top one audio, video, participants, etc.
Sorry, sir.
On the top, I am seeing audio, video, participants, chart, etc. on panel. Can we close that
1 second.
at the top? Okay, fine, great. So you all know regarding the Sustainable Development Goals, which have been developed by the United Nations organization, and which have been accepted in the year 2015 as a continuation of the Millennium Development Goals, which could not be achieved in full. So that is the context. So the idea is to provide equal opportunities for all, and to have a sustainable air planet, and to ensure that the poverty, hunger, etc., and inequalities, and access to water and sanitation, and sustainable development, and environmental sustainability, and climate action, and peace and justice, and strong communities, strong institutions, and partnerships for the goals. These are the overall this thing. So they are 17 in number. They are supposed to be attained by the year 2030. These are the goals. So out of them, if you see, goal number 6 is the goal towards clean water and and safe sanitation. So clean water and safe sanitation, if it is achieved, then it will have an impact, positive impact on the reduction of poverty or no poverty, and zero hunger, and good health and well-being, and for girl children, quality education, and gender equality for the girl child, and decent work and economic growth, And goal number 9, industry, it will also enhance the industrial production, etc., and reduce inequalities to some extent. And cities also can be sustainable from the point of view of water access and water quality, better water quality, and responsible consumption production. That is the to ensure environmental sustainability. We have to use the water in a responsible way, water and all other resources also in a responsible way, and production also, industrial production, water production, aquatic organisms, like, and it will also, because future wars will be fought for water, as we are already seeing our the neighboring countries trying to control the flow of water through Brahmaputra, and like that. And peace, justice, and so proper water management will also further or add to the cause of peace, justice, and strong institutions, and partnership for the goals from all concerned institutions, both national and international institutions. So we'll see what consists of clean water and sanitation. Main targets. Out of 8 targets, 3 are the main things. So sustainable access or universal access to clean drinking water. It should be affordable and it should be accessible. It should be clean. So by the year 2030. So that is one of the targets regarding water supply, clean water. Regarding clean sanitation or safe sanitation, it should be affordable, it should be accessible, and it should be sustainable. It should be safe. So that is the idea. And we should also have hygiene also should be added to that one. Because only through proper personal hygiene we can prevent 40% of the diarrhea disease, the puff, personal hygiene and environmental hygiene. So open defecation, end open defecation, and equal opportunities regarding the safe sanitation to women and girls, so that they can meet their sanitation needs. Similarly, wastewater treatment and waste management. These are the last main target. So having a proportion of untreated wastewater, be it domestic wastewater or industrial wastewater or agricultural wastewater. Then promote the safe reuse of the wastewater that is produced after treatment. So we'll see what is the water availability scenario in India. So you can see the how the people are clamoring for water. This is the situation in many of our villages. And if you can see the right side top diagram, you can see by 2030, the demand will outstrip the supply by double. So supply will be less than half of the demand. So that water scarcity will be rampant by the year 2030. Already we are facing it. 54% of India already faces high to extreme high water stress already. So almost 600 million people are facing this scarcity. So we can see Falkenberg water stress indicator. He is a planner and engineer who has indicated that based on research that the minimum availability which is required for a human being is about 1700 cubic meters per capita per person per year. Against that, our present availability is about 1341 cubic meters per capita per year. That means we are already, if it is less than 1700 and above 1000 or 1000, between 1700 and 1000, it is considered as water stress. So we are already under high water stress, as we can see at the bottom right hand corner. So and so many areas in the country are also facing water scarcity. That means less than 1000 cubic meters also they are facing. And India is 13th most water stressed country globally. Our water quality index recently is 120th out of 122 countries that have been surveyed. So average water supply in the urban local bodies is about 70 liters per capita per day against the service level benchmark of 135 liters per capita per day for small towns, less than 10 lakh population. Okay, so I invite the participants to ask as many questions as possible so that we can make it more interactive and learn from each other. So on the top left hand corner, you can see more than 100 million people live in areas of poor water quality. Water quality maybe in the context of fluoride, excess fluoride, or iron, or arsenic, particularly in the eastern, like West Bengal, like that. And if you can see that right hand side diagram, you can see Himachal Pradesh, particularly the Punjab, Haryana, and Delhi and Uttar Pradesh, and Maharashtra and Gujarat are most affected, and Punjab and Maharashtra also are most affected, including Ladakh and Jammu and Kashmir. So most affected due to poor quality of water. So national average is 73.8%. Against these are less than say 70% or 50%, 55. So this is the main extensive main poor quality of water. We have to strive to address the issue squarely. So if you can see, let us understand what is the situation regarding the impact of health impact of water pollution and lack of access to clean water in India. The mortality, that is the annual death toll due to poor water quality, comes to about 2 lakhs to 3 lakhs per annum due to unsafe water, sanitation, and hygiene. So both water, sanitation, hygiene. On the it is poor water producing diarrheal diseases. They are killing about 1 lakh children under 5 years age each year. So in 2025 and 26, urban water crisis, you can see even in indoor also, about 14 children have died, about 14 people have died. Water quality problem or water contamination due to old or sewer lines, which are contaminating the water supply lines. So there are 34 deaths in minimum 15 cities during 2025 to 26. So due to this, there is a morbidity, that means hospitalization and incapacitation, and they cannot be productive. They cannot go to their employment. This is also kind of adding burden on our country. 30 million cases of waterborne diseases are reported annually. Common illnesses are diarrhea, typhoid, viral hepatitis, and cholera. And infrastructure failure. Many old corroded pipelines are there, and cross contamination is there between sewage and drainage pipelines, and stormwater, or even solid waste is also contributing. And contamination and access gaps. Almost 70% of surface and groundwater is unfit for consumption. For example, about 311 river stretches out of 605 rivers are contaminated. That means more than 50% of our water bodies are highly contaminated. So chemical hazards, more than 100 million people are exposed to fluoride, arsenic, iron, etc. in groundwater. So almost 70% of our groundwater sources and surface water sources are polluted. So access also is a problem. So more than 90% have better access, basic access to water supply, but at the premises on the within their houses, only 55 to 60% have got safe water. So India is losing almost 73 million man days per annum due to the poor water quality and access problems. Economic burden is about $600 million dollars per annum. So we are losing about 3%, 4% due to poor water and sanitation and hygiene in our country every year. So that is the condition. So you can see on the top right hand corner, most of the rivers are polluted, including the Musi River in Hyderabad, and Kuam River. Kuam River is the most polluted in Chennai, in Tamil Nadu. So sustainable water management. What does this consist of? So particularly in urban areas, you have got the environmental sustainability, where you have access is restricted, and pollution is rampant, and contamination, water contamination from solid waste, from wastewater, and industrial wastewater, agricultural wastewater, and sewage, domestic sewage also is rampant. And there is a lot of financial constraints we are facing because it is a developing country. We have got competing financial requirements. We are also facing financial constraints also. And low literacy are about 70% in our country. So that is also contributing to not understanding, lesser understanding of the importance of clean water and clean safe sanitation, etc., and hand hygiene, and there is personal hygiene and environmental hygiene. So these are the sources of water. You can have a borewell, you can have a lake or tanks, etc., or you can have drinking water pipeline supplied through pipelines, and rivers, streams, canals, etc. And the principle is the consumption as much as possible and reuse the water wherever possible. For example, your grey water or used water in industries, etc. And you can also recycle. The domestic wastewater can be treated. Treated effluents can be recycled to industries like that, which Nagpur is doing, many Visakhapatnam is doing, many places, even industries, IOCL, etc., are also doing. And smart water management, for example, in Vijayawada Municipal Corporation, in Visakhapatnam Municipal Corporation, and in Tirupati Municipal Corporation, and in many bigger cities like Bombay, etc., they are doing the smart metering and leak detection systems and SCADA system, etc. So the technology also helps to provide better access and better control and monitoring and better operation maintenance of the water supply systems. So you can see what are the conservation strategies. For example, IGBC, the Indian Green Building Congress. For example, in Hyderabad, there is one Sorabji Godrej Green Building building. So there, you are conserving water, you are conserving energy, you are conserving natural resources, you are using the natural ventilation and lighting due to sunlight, etc. So in that way, we can make the buildings also green or positive towards towards sustainability. So you can have demand management strategies like low flow fixtures or dual flush groundwater recharging and grey water recharging, and also supply side management strategies like limiting the quantity of supply through control valves in order to reduce the peak flow into these things, and reduction of unravel water, which also includes the physical losses also. So not only the financial losses, but physical losses also. So process reuse or inject water for flushing, gardening, and washing wherever feasible. So if we can see the water loop, Singapore, we have been to Singapore from government expense. So I'm thankful to the government of Andhra Pradesh, that is restful Andhra Pradesh. So what we have observed in Singapore is they are actually importing water from most of their water requirements from Malaysia, Indonesia, like that, nearby countries. So because it is a city state actually. It is less than Hyderabad size of the Hyderabad, and population is also less than Hyderabad city. That is GHMC, Greater Hyderabad Municipal Corporation. So still their water management strategies are really worth appreciation. So they are managing the storm water, they are managing the rainwater, and also seawater, etc. And the storm water is also collected in 17 reservoirs. So they have made a waterway. So reservoirs are connected. So then the raw water is treated to potable standards. The Public Utilities Board is there. It is in charge of the water treatment processes. And that is transmitted to industry and households. And whatever water, the seawater is also treated through desalination, and that is also transmitted to the industries and the households. Then the collection of the used water is also collected across a length of pipelines of 3,500 kilometers of sewers, and the underground sewer system is there. So deep tunnel sewerage system. So that is also a new technology. And the water treatment is used, treatment of used water, that is used water effluent, at four water reclamation plants. And they are producing very high quality of water, that is what they call new water, which is used for factories and also for households. So even I have got drunk the water which is treated, that is wastewater, treated wastewater to a high quality of treatment. So they have actually done a wonder also. In 1977, the Lee Kuan Yew, who was the Prime Minister of Singapore, he has thrown a challenge to the engineers and planners. Can you clean the Singapore River in 10 years? That is his challenge. So the officials have taken up the challenge, and they have cleaned the Singapore River into a pristine pure river, which earlier it was highly polluted. In 10 years, they have made it, they have transformed it into a clean river. And we have seen that it is giving to, we can even travel through boats, etc. And water body is very clean, and it is supporting the aquatic animals, aquatic organisms also. So in Odisha also, another good practice is in Odisha, they have taken up a scheme like drink from tap mission. So they were successful in that one. So they have provided universal access and metering to all households. They have reduced the non-revenue water and given house service connections. And community partnership also they have ensured. Jal Sathis, they have engaged 5,000 women, paying some nominal amount. They were very helpful in managing the last mile service delivery, the last mile connectivity. And smart water management, that is using the Internet of Things based systems and the whatever sensors are there. So they can monitor the entire water supply system on real-time basis through command and control center. Similarly, infrastructure modernization also they have done, water treatment plants, distribution network, GIS mapping, etc. And capacity building also through WATCO, that is one company they have floated for Odisha Water Academy. And that has also helped in building the capacity, enhancing their capacities of the concerned people, officials, etc. And public awareness, that is Pure for Sure, that is the campaign. And they have also employed a lab on wheels, there is a mobile lab on wheels and real-time quality displays. So this is one good practice. And they have also build public confidence in the tap water quality. That is what we have to give to the people. So by you make it transparent, put it in your website through posters, etc., like that. Unless we transfer the knowledge or any information to the people, they cannot know the good things or poor things we have done. So they will know and they will give their feedback. Then only the truth and transparency only we can improve the water access and water quality. In Madhya Pradesh, I have been to Madhya Pradesh and worked there as a consultant. So I'm thankful to Madhya Pradesh people. There is one institution which is working on water and land in Madhya Pradesh. So they have employed a term wise water management. I'll be discussing 3 or 4 issues. Rainwater harvesting. So what are we doing here? We are actually capturing the rooftop rainwater from the households, and also the rainwater that is flowing in the compounds, even in the roads, school compounds, college compounds, industrial compounds. Then that also we can actually capture it based on the gradients. And whatever cleaning is necessary, we can clean it. That's a purification. And then you can even use it in Hyderabad. From ICRISAT, there is one administrative officer, and he is using only rooftop rainwater which is captured for even drinking purposes. He doesn't have any municipal connection also. So that is quite possible. There are two options, 2 or 3 options in rainwater harvesting. One, you need not provide any lining for the rainwater harvesting structure or pit, and you can allow it to seep into the ground and raise the groundwater table. Okay, that's one option. The second option is you can capture it, you can clean it, and you can use it for other purposes like your car washing or floor washing or gardening purposes or horticulture purposes. The third option is which is a little bit more difficult, but you can do that because in Hyderabad some people are doing that. So you can use it for drinking water also after some filtering and disinfection, etc. Okay. So what are the criteria for design? As you all know, the gradient, the land use pattern, the soil type, the permeability of the soil, the rainfall, all these things influence the design for the rainwater harvesting structure. So the design involves collecting rooftop rainfall runoff or from open area or runoff from open area. So it may be a check dam also. You can have a check dams across a stream and collect the rainwater this thing. Or you can also even recharge the groundwater, recharge the borewell through the harvested rainwater. And you can also desil the lakes, similarly contour trenches and shafts to store the rainwater. So this is how the rainwater harvesting works on the diagram. So the rainwater falls in Kerala. They are doing it in a wonderful way. So I have seen in Kerala. So rain falls and it is better to have a sloped roof so that the whatever runoff water is there from the rainfall, it can be collected in a gutter and it can be taken to the piping. And there may be a filter also. You can have a filter. You can have a grating here also, which will capture the whatever silt etc. is there, leaves etc. You can filter it and then you can store it in the tank, and then you can pump it to the overhead tank or directly for garden washing etc., or you can pump it to the overhead tank and there from by gravity you can supply water for toilet flushing, car washing etc. So this is how it works. The overflow can be taken to the groundwater for groundwater recharge or to a well. So this is a typical design of a rainwater harvesting structure which has been done by the Hyderabad Metro Water Supply Board. So there are different designs depending on the size of the house. So this is a typical a smaller for a smaller house. It is more applicable. You will have different layers. About 1.8 meters depth of the rainwater harvesting pit, which will have 40 metal at the bottom, about 50%, about half the depth, and then 20 metal for about 25, one-fourth of the depth. And on that one, there will be coarse sand. Okay. So the important thing is you have to, the maintenance, the operation, how do you operate it, how you maintain it is also important because the top layer will be silted up. So you have to remove the silt from time to time. So that is the only operation maintenance team, this thing. And in order to have ensure that the top layer of sand doesn't get disturbed, disturbing the lower ones, so you should have some sort of arrangement. So flashing should be arrested. This disturbance should be arrested. So you will have a concrete like thing at that place where the water falls from the top. Okay. So this is the plan and section. So then we come to the groundwater recharging. Why groundwater recharging is important? So in India, almost 70% of our groundwater is contaminated, and you are facing acute groundwater depletion in most of the areas, even in the Gangetic Plain. So that is the unfortunate thing, particularly in Punjab, in urban areas in Punjab, Haryana, Himachal Pradesh, Delhi, in Gujarat, etc. Even in Maharashtra, in Karnataka, almost in 70% of the places. That is the gravity of the situation we are in. So net reduction in groundwater table is due to what? Falling rainfall. So over the years, rainfall is falling. That means overall rainfall may be little bit this way that way, but the most of the rain which is to fall over the period of about 3 months, 3 months or so, it is falling only in 58 to 62 days. So the number of rainfall days have been coming down over the years. Whatever due to whatever climate change or whatever this thing, particularly due to climate change, indiscriminate groundwater extraction, particularly in the Punjab region, etc. Indiscriminate groundwater extraction. So groundwater recharge is not in consonance with groundwater extraction. Extraction is much more than recharge. So which will make the groundwater aquifers completely emptied and not able to cater to the needs. So due to heavily paved roads and spaces, road spaces, etc., built up areas, etc., and removal of vegetation, so there is no recharge of groundwater and scanty rainfall. So all this leads to non-availability of groundwater and low availability of groundwater and groundwater salinity, unsustainability of the groundwater aquifers, and soil infertility also results due to this one. So this is how you recharge the groundwater. So from the natural source of recharge water, that is it may be a rainfall, normal rainwater harvesting structure or any other source. You have to pump through the pump water into the ground the borewell through an injection pipe, and it will recharge the groundwater table and the groundwater this borewell. So this is how it works. So this is also a very good option to rejuvenate a dried up well like that. So grey water composition. So we have discussed regarding the rainwater harvesting and groundwater recharging. Now we come to grey water composition. What is the extent of grey water? It is almost 62% of the used water is grey water. So what is grey water? It consists of the kitchen wastewater, utensils, etc. What we wash, the wash water, the sinks, etc. The bathroom sinks, the bath water, and the laundry water. All these three components constitute our grey water. So out of the 62% of grey water, about 49%, almost half, we are using for shower and bath. Okay. So then wash basins, hand basins, 7%, and laundry, 27%, kitchen, dishwashing. So this is the context in which we will discuss the next this thing. So grey water recycling. So the water which is coming from the overhead tank or direct this thing, it is being consumed by the kitchen and the water purifier and the bathroom and the laundry. Okay. This is all what we call the grey water. Okay. Or sullage we can call. So all that is collected in a collection chamber. Okay. Then it is filtered and it is also treated, preferably through constructed wetlands because there is nature-based solutions. And then after treatment, it is stored and it is again pumped to the overhead reservoir, a separate reservoir, separate water tank, not the regular water tank, but a separate water tank, and it is supplied through by gravity to the toilets for flushing and for floor washing and car washing and gardening. There are standards for that also. So it's not that directly it is used, but it can be, we may need sometimes to disinfect it through UV treatment or whatever it may be, whichever is feasible, right? So these are the standards for grey water. These are the characteristics of grey water. This is the grey water. This is the raw sewage. So it's much better than raw sewage, but still it also needs some sort of treatment at the domestic level as well as at the industry level or at the water, in water treatment or whatever it may be. In Raghavapur water treatment plant, we have been to the Mission Bhagiratha scheme for an inspection in Raghavapur in Telangana, nearer to Hyderabad, Parigi Mandal. So there is a water treatment plant. There, what they are doing, what they have planned is clariflocculated sludge is planned for recycling. So in that way, they are trying to recycle the clariflocculated sludge water, which is separately collected. So the grey water can also be recycled for use in toilet flushing, as we have discussed. And what we are doing here, we are actually giving back to nature. We are giving it back to nature. So that is what we have to understand. So another aspect. So this is a little bit more technical. This is the International Water Association. This is the water audit. This is water balance study. Water balance. How do you make a water balance study? What is water balance study? What is going into the system? What is coming out of the system? is it equal, or is there any gap between the water that is flowing into the system and which is coming out of the system? So that is water balance. So we'll see system input volume. So what is the input volume that is being input into the system, water supply system? So there is, out of that one, there are two components. One is the authorized consumption. The second is the water losses. So authorized consumption is you are authorizing it. It's an authentic consumption. Out of that, there is a billed authorized consumption and unbilled authorized consumption. Okay. So you are getting billed authorized consumption, you are getting money. Unbilled authorized consumption, you are not getting money. Okay. In the water losses also, you are not getting any money. Apparent losses and real losses. Apparent losses means unauthorized consumption and customer metering inaccuracies will be there in every this thing. Similarly, billed authorized consumption consists of billed metered consumption, billed unmetered consumption. So there may not be a meter, but still it will be billed. Okay. So that's why it is a revenue one. You are getting money for that one. But unbilled authorized consumption does not give you any money. Unbilled metered consumption, unmetered consumption also. If you do, even if it is metered consumption, if you don't bill it, then you don't get any money for that one, isn't it? Similarly, real losses, that is leakage from the reservoirs, leakage in the transmission mains, leakage in the distribution system at the point of use across the house service connections, all this constitutes real losses. So the other unbilled authorized consumption, apparent losses and real losses, they constitute the non-revenue water. So you don't get money for that one. Okay. So you can reduce, how can you reduce the non-revenue water? There are two ways. One is the passive leakage control, another is the active leakage control. Passive leakage control is on inspection, on visual inspection mostly, you can identify where is the leakage. Suppose there is a overflows. Suppose there are leaks from the joints or pipelines, etc. Isn't it? So you can identify. Suppose there is a wetting on the surface itself. You can identify there may be a leak there. So this is passive leakage control. Whereas active leakage control is you will investigate. You can use leak detection cameras, etc., leak detectors, leak noise correlators, like that. Some equipment are there, leak detection equipment. So through them you will identify them, and you will have a detailed plan of action. It needs consultants, it needs a lot of capacity building, and needs technology and equipment also. So that is a little bit more difficult. So that's why at least we should aim at passive leakage control. Whatever is apparent, whatever is visible, you have to first take up that the control of that type of leakage. So life is after all a celebration, my dear friends. So let's take a 1 minute break. I will sing one song, a small song. सारे जहां से अच्छा हिंदुस्ता हमारा हमारा, सारे जहां से अच्छा हम बुलबुले हैं इसकी, ये गुलसिता हमारा हमारा, सारे जहां से अच्छा हिंदुस्ता हमारा हमारा, सारे जहां से अच्छा. So our country, we are proud of our country, and we value its rich heritage, and also its water bodies, its resources, its rivers, its canals, its valleys, and its forests, etc. So are we managing them in a responsible way? That is the question we have to ask. Are we ensuring environmental sustainability, environmental protection, forest protection, and river water conservation, and river cleaning up? And are we taking the responsibility? Are we taking the stewardship of the water quality and water quantity, etc., water quality protection and water bodies protection? That is the question. So then only we can say our country is great. Sare jahan se acha, we become top in the world. So let's come to the subject. So in Vijayawada, we have worked. In Vijayawada Municipal Corporation, we have got a SCADA system, that is supervisory control and data acquisition for the water supply system at the headwater works. We have got a SCADA system where the sensors are metering is done for various parameters, just like energy meter, water meters at the raw water stage, at the clear water stage, and chlorine meters. There is chloroscope, this thing, and there are sensors attached to that one, and all these sensors capture the quantity of flow and the chlorine levels and also the water levels and the energy parameters like your power factor meter, what is the energy consumption in terms of the demand as well as what is that the consumption in terms of kWh, like that. And it will also capture the pH also and turbidity. So there are separate the sensors for that one, and the sensors will capture the data, the readings, etc., and they will supply to the RTU, that is the remote terminal unit, and from there it is supplied to the cloud. At that time, cloud was there, not there, and it was directly sent to the command and control center, which is located in the headwater works. So there is a human machine interface. Oh, 1 minute, 1 minute. One minute. Please wait. One 1 minute. Please wait. Yeah. Sorry for the interruption. So, am I visible? Am I audible?
Yes.
Am I audible?
Yes.
Sorry for the interruption. So, all these parameters are captured by the RTUs and sent to the some command and control room where there is a human machine interface. That means human beings will be there and computers will be there. And on the computer, real-time monitoring will be done regarding the water levels, regarding the pressures, etc. Suppose there is a pressure fall at some point of the transmission lines, etc. So there we can identify that there may be a leakage at that point. So we can send our linemen and get it repaired immediately. So that is advanced. Suppose there is a overflow in the reservoir based on the water level in the reservoir, we can identify whether there is an overflow or not. So if there is an overflow, then we can we can immediately give a message to the concerned operator to stop this thing. And even from here also, from the command and control center also, we can control that one. So the overflows can be controlled, the leakages also can be controlled, and pressure losses can also be controlled. So that means real-time monitoring. That means continuous monitoring will help in managing the water supply in a much better way, and even in controlling the water pollution also, and water losses, etc. Okay. So this is the advantage of, and even in emergencies also, the SCADA system has helped a lot. So you can divert the water supply from one system to another system by giving certain interconnections, just for a buffer, for a backup. So that is also the advantage. So in a flood in 2009 September, that has been very useful in diverting water to where water supply has failed. So that is the advantage of this SCADA system. So this is yeah. So these are the 56 reservoirs which are located in Vijayawada. So on all the parameters have been captured, the water levels, low water level, high water level, etc. And the size of the reservoir, the capacity of the reservoirs, etc. And this constant monitoring was there. So through that one, we can identify which reservoir has filled up, which reservoir is overflowing, and which reservoir has been successful in capturing the required water. So the water levels, the water quantity also can be captured as shown in the right side this thing. So there are three circles in Vijayawada. So we can find out actually the MLAs, the members of legislative assemblies have been demanding our area is not getting water. So we could counter them. So no, we have supplied you sufficient quantity of water. This is borne out by the data with us. So then they can be satisfied like that. So in Tirupati also there is a smart water management. So that is a little bit different type. There was one about 1100 PSC pipeline which was leaking heavily. So that's why original proposal was to replace the entire pipeline. But later we could one IAS officer by name Giridhar has been instrumental in engaging the services of one expert from US. He's an Indian expert only, and they have devised a software, KY pipe software for controlling or for complete continuous monitoring of the pressure levels in the pipelines. Suppose the water hammer pressure. So water hammer control devices can be designed based on the KY pipe software findings, the outputs. So that is the advantage of that system. Thereby, we could save a lot of money also and better control over the system. So it involves smart water management, which involves strengthen the existing system and 24/7 monitoring. That means online monitoring and equitable distribution to all the areas and the hydraulic SCADA. Okay, so it involves air monitoring system, air management system, fixing the leakages, etc. There is rehabilitation of the existing system, and also the pump and motor health. The hydraulic parameters like pressure and flow rate also are captured, and water quality also captured, and energy consumption is also captured. Similarly, equitable distribution of water supply through better reservoir management. Through hydraulic control valves. So there is no manual this thing. So hydraulic control, how much water has to go into the reservoir, how much water has to come out. So water distribution management system, that is also automated. So in that way, we could have a excellent control over the reservoir levels, reservoir quantities, capacities, etc., and also the distribution management also, and continuous online real-time monitoring through hydraulic SCADA system. So the performance of the water supply system was there is a specific clear-cut improvement and also improvement in the efficiency. Is in Tirupati. So actually, they have taken up one area, one ward for as a pilot, and they have fixed meters for each and every household and sensors also, and they have metered them, smart meters. Thereby, online or continuous water management was done. So how much water is flowing into each system, each house. Suppose a householder says, I have not got water. No, mister, you have got water. We have been supplying water. This is the data. So in that way, we can actually customer relation management also we can do in a better way. So these are the various contaminated drinking water diseases caused by various organisms like diarrhea, cholera, dysentery, typhoid, polio, hepatitis A, like that. These are the major diseases apart from minor diseases. So what do the Indian standards manuals say? For example, we have got Bureau of Indian Standards, IS 10500. That is the water quality parameters, both physical, chemical, bacteriological, virological also. Similarly, to IS 2065, building water supply standards. Similarly, IS 1742, building drainage standards. Similarly, we have got the National Building Code, which is revised in 2016. Part 9 talks about the plumbing, water supply, drainage systems, etc. Similarly, we have got CPHEO, that is Central Public Health and Environmental Engineering Organization. Water supply manual is there. And there is also another manual, water supply O&M manual, operation maintenance manual. You have also got a CPHEO, drainage and sewerage manual, which is published in 2023. And also you have got CPCB, that is Central Pollution Control Board, and Ministry of Environment, Forest and Climate Change, water supply norms, and also pollution norms are also there. So this is the this thing. So you have got a lot of standards, and they are being continuously updated also. The standards are being revised and updated. So you have got this IS 10500. These are the organoleptic and physical parameters. Okay. We have got chemical parameters and bacteriological and virological also. Okay. So then what are the major pollutants to be measured in the water supply, particularly wastewater? So what is the oxygen demand? That is the BOD, the biochemical oxygen demand. That indicates the extent of organic pollution in the water. Similarly, COD, the chemical oxygen demand. That also indicates the organic and inorganic pollution in the wastewater. Okay. Then nutrients, particularly nitrogen and phosphorus, because they lead to eutrophication of lakes, etc. Like that. Then we have got the indicator organisms like bacteria, fecal coliforms, fecal specific, and Escherichia coli. This indicates the extent of fecal pollution. That means due to the excreta related pollution. So they are specific to humans. The Escherichia are specific to humans. Solids content. So total suspended solids. This is also monitored. Nowadays, the forever chemicals, persistent organic chemicals are also coming. Pesticides, insecticides, etc. The residues, all those things are also problems, areas of concern, which the PFAS, that is parent polyfluoroalkyl substances, which are being monitored in the United States by the EPA. We don't have so far standards regarding that one. We have to develop them. This is the runoff. This is surface runoff, and how pollution is happening from the domestic wastewater, from the industrial wastewaters, and also from the agricultural wastewaters. All these wastewaters contribute to water pollution, right? So these are the pipes, materials pipes. For example, these are DWC pipes. That is what's that? These are also HDPE pipes, double wall corrugated pipes, and these are the SWG pipes, that is stoneware glazed pipes. Similarly, RCC pipes, UPVC pipes, CPVC pipes, particularly for internal water supply, we use them. PVC pipes. Okay, these UPVC pipes we are using for water supply pipelines also. PVC pipes are normally for outside these things. So HDPE pipes. This is a good material which we have used in our APUSP, that is Andhra Pradesh Urban Services for the Poor, which is a DFID British government aided project, and DI pipes also. These are mostly used for water supply and even for sewerage system also. So double wall corrugated pipes, HDPE pipes, and DI pipes. So we got different codes for that one. So plumbing systems. So how you design for plumbing systems? So nowadays, due to the water scarcity, we have to go for extensive saving of water, conservation of water. So you can have water efficient washing machines, that like washing machines. For example, front loading washing machines, they conserve a lot of water. For example, you have got showers. You can have low flow shower heads. You can save easily 30% of water. Similarly, taps also. You can have quarter turn, half turn taps like that. With flow restraints, you can save almost 50% of water. Similarly, you can have adapters fixed to the taps. You can save easily about 50% of water. By using simple mug instead of flowing water from an open tap, you can save more than 60 to 70% of water. So there are two types of plumbing systems: direct water supply system, indirect water supply system. So what is the difference? Direct water supply system, you directly pump water. If the pressure is adequate, it will be directly pumped. If the pressure is not adequate, you put a pump and put a overhead tank, and through the overhead tank, by gravity, you will supply to the various installations, various equipment or appliances. Okay. So you can have direct overhead or pressurized. You can have different types of materials, pump pipe materials, and backflow prevention and smart pumping sensors is important. So you have to prevent backflow, siphonage, etc., so that there is no contamination of water. Okay. So fixed traps. There are different types of fixed traps. So what is the use of those fixed traps? They prevent the mosquito menace, etc., and any cockroaches, etc., and also gases. Also, they will prevent. Okay, germin entry, sewer gas, etc. So you have to provide air circulation for the drainage system to function properly. So foul air exhaust is also important for the vent terminal, etc. And all vent pipes should be provided with a cowl. That means on the top of the vent pipe, you should provide a cowl, so that there is no entry of these mosquitoes, etc. So in the diagram, you can see the water seal. See, this is what is known as trap seal or water seal. So that should be nearer to about 2 inches, up to about 2 inches, 2 to 4 inches maximum. So these are the different types of traps, PQS traps. So P traps are used mostly for wall fixed these things, and for Q traps for floor fixing. S trap is not generally advisable because it leads to back siphonage. So there are different types of stacks for domestic or commercial or whatever it may be. So drain stack and traps and vent pipes. These are the three important issues. For example, this is the thing. This is the drain stack. Okay. These are the traps, various traps, P traps, Q traps, S traps, whatever it may be. And fresh air inlet. So it enables fresh air inlets. Okay. So clean out. For clean out, first covering. This is connected to house drain. So what does the vent pipe do? It regulates the air pressure within the drainage system. And it also allows the sewer gases to escape. So how do you identify the choices for pumping pipe system, for pipe plumbing system? So one is the single stack system, which is the most cheapest system, which is very simple. And there is no vent pipe. There is a single waste and soil pipe, and there is no trap ventilation. It is ideal when the toilet or fixture layouts are repetitive. That means at the same location in different these things, different floors. So that is the system, single stack system. So this is another one pipe system where there is a ventilating pipe. So all these things, traps are connected to the stack pipe, the waste and the soil stack pipe, and ventilation is done to the ventilating pipe. So the vent is connected to every trap to prevent them from being siphoned out. So this is a little bit more expensive than the single stack system. So this is another system, single stack with partially ventilated system. So generally there is a relief vent pipe installed. So this is the relief vents. Okay. So this is how from the vent pipe the air outlet will be there, so that gases are prevented and vermins are prevented. Another pipe system is also there. Two pipe system. Here there are two pipes. That means there is a soil pipe and waste pipe. This is for excreta, soil pipe. This is for other wastewater. So each pipe has got different connected to different ventilating pipes. This is more costly. So all the plumbing fixtures will be connected to the waste stack through deep seal. There will be deep seal trap. That is what we seal, water seals, so that it prevents the gases, etc., and back siphonage. So two pipe system. There is a common vent stacks. There is a two pipes, soil pipe and waste pipe, and there is a common vent. This is a common vent. So this is how it works. So all the soil appliances will be connected to the soil stack. So friends, any questions, please? Any questions? So, okay, if there is no question, life is after all a celebration. We will celebrate with a song. This is one song from film Madhumati, which is a very old song, where the, the 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 uh, the main man sings a song, the hero. So, सुहाना सफर और ये मौसम हंसी, सुहाना सफर और ये मौसम हंसी, हमें डर हमें डर हमें वो आसमां झुक रहा है जमी पर, ये मिलन हमने देखा यहीं पर, वो आसमां झुक रहा है जमी पर, ये मिलन हमने देखा यहीं पर, मेरे दुनिया मेरे सपने मिलेंगे शायद यही, सुहाना सफर और ये मौसम हंसी, हो 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 हो। ये गोरी नदियों का चलना उछल कर के जैसे अलहड़ चले पीते मिलकर, ये गोरे नदियों का चलना उछल कर के जैसे अलहड़ चले पीते मिलकर, प्यारे प्यारे ये नजारे निगार है हर कहीं, सुहाना सफर और ये मौसम हंसी. Dilip Kumar is the hero. So, how I relate this one is, he talks about the pure water bodies, and we are concerned about the water bodies, that is water health, water quality, and water adequacy. So, by keeping the water bodies pure, by taking necessary measures, by taking the leadership ourselves, and mentoring the young people like children, students, etc., and youth, etc., for taking the stewardship of water bodies, water quality improvement, lakes and other tanks, etc., wells and rivers also, and preventing pollution through plastics or any other solid or liquid waste, etc. So there is one, we'll come to the house drainage system now. So in the house, you have got the gutter, as we have seen in the Kerala this thing. So you have got the bathroom, toilet, laundry, kitchen. These are they produce the sewage water or grey water. So if you treat the sewage water and grey water, the grey water properly, and you can utilize it for other purposes, like for your the gardening or car washing or floor washing or even horticulture, like that you can utilize that. Whatever excess water is there, you can add it to the sewerage system. Okay. So this is the water main, of course. So this is stormwater lateral. There is a separate stormwater system. In India, because the rainfall is not, rainfall is concentrated within 3 months, and that too within about 70 days, less than 70 days, we cannot go for a combined sewer system. Our system is a separate sewer system because of the seasonal rainfall, unlike the European countries. Okay. So these are the urinals and sinks. So you have got the dual flush system. There is a separate flush for toilet and separate flush for urinal. So this is the dual flush system. You save a lot of water by this one. Water-free urinal cartridge, water-free urinal cartridge. Similarly, by using adapters, by fixing adapters, quarter or water, half turn taps, etc. You can save and a low flow this showers, etc. You can save plenty of water, more than 60 to 70% of water. This is a bedpan sink in a hospital or in even in a household also. So stormwater management. How do you
But
manage the
can I say
stormwater? Are we
something?
using the stormwater in a much in a responsible way, in an environment friendly way? This is the question. So we are going for hard infrastructure, that is grey infrastructure. So, but is it producing the results? So as far as possible, so suppose for example here there is one septic tank. Okay, so you can even treat it here, this is the grease trap. So this septic tank where a combined sewage is going in. Okay. So you can have recharge pit for the storm water to manage it by through rainwater harvesting and groundwater recharging. And here you can in the septic tank you can separate the oil and these things. Generally, septic tanks are used for a mixed sewage. The mixed sewage, that means grey water and storm water both combined. But grey water and black water, that is the toilet waste water combined. So probably it may not be that much relevant here. So here in stormwater management, how do you design the rainfall? You use the IMD data and you formulate the IDF curves, that is intensity, duration, frequency curves, and thereby you arrive at a balanced rainfall, which your financial system permits. And you can include silt traps and oil interceptors and recharge pits also. And by using permeable pavements and bioswales, that means by the plant-based swales, that is kacha drains also, you can enable infiltration of the stormwater into the ground or runoff into the ground, so that you can reduce the stormwater runoff over the ground. So these are the options for sustainable urban drainage system. Different people call differently. Suppose, for example, water sensitive urban design. Similarly, blue-green infrastructure. Like that, different low impact development. Like that, different people or different countries are calling it different way, but almost all are overlapping. So this is one biosphere. So this is one swale. So here there is a vegetation. Here there is no vegetation. So there are green gardens. Okay. So like that. There is a specific design pattern. So nowadays, even GHMC also has called a tender where they have specified blue-green infrastructure or water sensitive urban design in their tender for developing this stormwater drainage study. So in sustainable urban drainage, these are other options. Infiltration basins. Okay. So there are cells, infiltration cells. So they will enable infiltration into the ground. Similarly, detention ponds. So they detain water for some time to reduce the peak flows downstream. So these are the soak pits like things. So these are the swales. So they are kacha drains, and these are filter strips. These are green roofs. In Singapore also you can see, even in our country also, at some places you can see green roofs. So infiltration trenches, these are infiltration trenches. This is bioretention areas. So wetlands, these are bioswales also, where there will be vegetation designed. So pervious pavements. Okay. So these are different types of blue-green infrastructure or sustainable urban drainage. Nature-based, they are also called nature-based solutions. They enable nature infiltration into the ground. So this is the green stormwater infrastructure, which we have already discussed. This is the conventional sewerage. This is hard infrastructure. This is green and blue infrastructure. Detention basins. Retention basin means it retains water. Detention basin means it retains water for some time only. Then it will be let off or it will be pumped. So you reduce the peak flow in that way. This is the curbside bioswales, permeable pavements. In Hyderabad also, in the one stadium, Cardigan Stadium, sports stadium, they have built the pervious pavements. So life is after all a celebration where children will be playing and we'll be enjoying with the children, and we'll be trying to mentor them for towards environmental sustainability and water conservation like that, and water cleanup like that. Wastewater management. So wastewater is the used water. That is the wastewater from the that is grey water, that is or sewage water, or the toilet water, wastewater, that is black water. Both grey water and black water both constitute the sewage or wastewater. So this is the industrial wastewater, right? And segregate the domestic and industrial wastewater. So generally what we do is, in our wastewater treatment, we segregate the main industrial wastewater. We don't mix the industrial wastewater and the domestic wastewater. We have got separate treatment system for the industrial wastewater treatment plants. industrial wastewater treatment plants, either for individual industry, if it is a big one, or CETP, that is combined effluent treatment plants or effluent treatment plants for a group of industries, so that the costs come down, their bottom lines can be sustained. So that's the idea. Then STP, sewage treatment plant for domestic wastewater, ETP for the effluent treatment plant for industrial, and reuse also. For even for domestic wastewater treatment systems, STPs, we can use we can reuse the wastewater for different purposes, or we can recycle it for industries or for agriculture, etc., or for horticulture. So that's how we will ensure circularity. That means we don't use waste anything at any point of time, any stage. That's the circularity principle. So typical domestic septic tank system. This is the septic tank, the cross section, the solid sewage, the solids, that is the sludge, the liquid sewage, and the scum, which it consists of fats, etc., which are deposited on the top, which will collect at the top. That's scum. So there will be a this thing. There will be inlet this thing obstruction, and there will be an outlet obstruction also. Okay, so that there is no short circuiting. What could call barriers. So household wastewater will flow into the system, septic tank, both grey and black water, and it will be collected in a distribution box, and from there it is distributed in the drain field trenches. They are shallow trenches, about 1.5 to 2 feet depth, with perforations. They are mostly they may be PVC pipes or stoneware glazed pipes. And here nitrification also happens. So the effluent from the waste, the septic tank is only partially treated. It's only primary treatment. The secondary treatment will be done through this one. Okay. You can also have a leach pit also. So this is the regular systematic wastewater treatment. This is the wastewater treatment plant layout, where there will be initially from the houses, the sewage will be collected through sewerage pipe network, and there will be coarse screens and fine screens, and then the grit and waste material will be disposed separately, and after the screening, coarse screening, fine screening, then it will go to the primary sedimentation tank, and the raw sewage which is collected, sludge will be collected, will be going to the sludge processing units, and then the effluent of the primary sedimentation tank or primary clarifier will be going to the aeration tank. This is the main bioreactor. So from there, after digestion of the sludge, the mixed liquor will be going to the final settling tanks. So some of the mixed liquor, a portion of the mixed liquor or recirculated sludge will go to the aeration tank, so that it will improve the efficiency of the bioreactor in the aeration tank. So the excess sludge will also be taken to the wastewater sludge processing units. So after the final settling tanks, the effluent will be taken to the recycled wastewater class B and C. So that's a little bit lower quality. Some of the portion will be subjected to tertiary treatment, and then it will be disinfected, and it is called recycled wastewater, class A. So that will be that can be used for indirect post-water drinking water use, and the downstream it will be treated. And industrial and domestic reuse also, it can be used, not for non-drinking, unless it is highly purified using RO process, etc. It can also be used for agricultural reuse. So this is how a bird's eye view of the wastewater treatment system, how it works. So in GVMC, there is a wastewater recycling. So they are actually out of 108 MLD of wastewater produced, almost 70 MLD they are treating to a level of treatment, and they are actually from Narva STP. They are selling the waste treated wastewater to the Hindustan Petroleum Corporation Limited and the Vizag Steel Plant, and they are using 7 MLD for gardening in a club, and 5 MLD for port trust. So they are getting money, almost about maybe about 40 crores or so they are getting per annum. So there is a PPP model, the public-private partnership model with the municipality and the private sector organization. There is a special purpose vehicle also created for that one, APUIMAML, a project management consultant is the consultant. and there is a special purpose vehicle also. So this is a very good practice. Nagpur also they are doing similarly. They are also getting quite a good amount by recycling the wastewater after treatment. That is effluent of the wastewater treatment plant to the thermal power treatment plant, thermal power station. Okay, so there are good practices. So okay, so far we have discussed what is relevant regarding wastewater treatment or regarding stormwater drainage or regarding the water supply or this thing. Okay, then what is the way forward? So what can we do as individuals, as responsible citizens and responsible officials, whether private sector and public sector? So what is the vision? Universal coverage. So to cover water supply and wastewater treatment, wastewater infrastructure, universal connections universally for every person, every household, and quality also we have to ensure. So what other things we can do? We can integrate the conservation, plumbing, and reuse of wastewater, reuse and recycling of waste. So one is rainwater harvesting, rainwater collection of rainwater and harvesting it, and then groundwater recharging. By thereby we can raise the groundwater table and make it available for the agricultural people and all farmers, and also for for others, for like us. Then grey water recycling, the sewage water we can recycle it by properly filtering it, and if necessary recycling it also to standards and bylaws. So we have to frame bylaws also for municipal bylaws, any industry bylaws. Without bylaws, we cannot have it successful. So non-revenue water reduction, particularly for municipal supplies, even in your townships also, industrial townships also, you can have non-revenue water reduction strategies, whether it is passive leakage control or active leakage control, using technology also, metering, etc. And adopt smart monitoring and water audits. Smart monitoring like SCADA system and water audits also can be done. Water balance studies like that. Mentor the children and youth for water safety and security. So now what we are doing. I am a retired man, so I am going to the children, I am going to the youth, and trying to inform them how the water quality is, how the water access is there, how we are polluting our water bodies, and how we can ensure that water conservation happens, and how we can clean up the lakes, etc., and how we can ensure environmental justice for the people, particularly for the poorer sections of society, and particularly for the people who are living nearer to the flood-prone zones and industrial areas, etc. So like that, we can ensure, we can also work towards environmental justice. And air pollution is rampant, and air pollution is also leading to water pollution, and in turn water pollution is also leading to some sort of air pollution. So both are also to some extent interconnected. So what we have to do, we have to take up the ownership. We are the stewards for the future of water and wastewater, water quality, water quantity, water accessibility, right? So this is how we have done. I was also a part of this one in Medikunta Lake, there in Hyderabad near Miapur. We have done one under the auspices of the Fountainhead Global School. The children were extensively involved, and they have cleaned up the Medikunta Lake this is the before cleanup, and this is the after cleanup, and we have made it into a wonderful water body where there are the people are enjoying morning walks, etc., and they are also, the children are enjoying. So like that, so we have to pave the way for the future. Every drop counts. So what are the key takeaways finally? So water conservation through rainwater harvesting, and also artificial groundwater recharge, and also non-revenue water reduction. Both it consists of both the physical leakages, also the physical wastages or physical losses, and grey water recycling. That is sewage water recycling, and also the wastewater effluent recycling also is there, and universal coverage of water supply and sanitation services, okay, to all the population, and recycling and reuse of wastewater effluent, as the Nagpur people are doing, and also the Vizag people are doing, Visakhapatnam people are doing at the industrial level as well as the household level also. And even at the household level also we can do that by properly reusing, recycling the RO water also, we can recycle it for domestic purposes, for downstream purposes. So environmental sustainability, water and energy conservation, energy efficiency. In Vijayawada Municipal Corporation also, we have taken these initiatives, water saving and water conservation through SCADA system also, and also energy conservation. Also the measures we have taken using VFDs also, and there is a variable frequency drives, and sustainable urban drainage system, water sensitive urban design or green infra, all mean the same almost. This is the need of the hour for stormwater drainage. Instead of going for regular drains only, we can combine it with these sustainable urban drainage systems, as we have discussed. Sustainable sanitation options. Both you can use nature-based solutions also, like constructed wetlands. Okay, nature-based solutions like your algae-based solutions, constructed wetlands, the KMS SBTC technology, soil biotechnology, like that. So I salute all the great people, our own governments, both central government and state governments, the CPHEO organizations, Central Pollution Control Board, CPHEO, BIS standards, and all people who have contributed to the mankind, humanity, by way of water and wastewater sector. And just only 2 slides regarding the essentials for success and fulfillment for the youth and the children and for others. See, it's not, the life is not only for enjoying, only for food and our eating, etc. So life is for contribution to our fellow beings. So we have to acquire knowledge and skills. Knowledge without skill is not, it cannot be actionable. So we should have knowledge and we should have skill, and we should have also the attitude to do the work. We are anyway getting salary. What should we do? This is one attitude. But having knowledge and having skill, if we want to contribute, we should have the right attitude that we have to contribute to the nation. We have to contribute to the humanity, like that, to our society, community. Similarly, we should have dedication and health. So that's why Sharira Madhyam Khalu Dharma Sadhanam. That means unless you keep up your health, good health, you can't contribute to the society. Similarly, integrity and character. Character is the crown of life. That's what Shakespeare says. So without character, we don't mean anything. We don't contribute anything. So creativity and innovation. So always we should be creative and innovative. We have to think differently from the conventional angle. So for example, if you see the right hand diagram, see what is success. So you're getting salary, you are having job title, we are doing your work in a very routine way. So this is one way of doing it. So you can be promoted like that, but it is only a partial way of success. So what is a better measure? You have the job title, you have the salary, you are contributing in a conscientious manner, in a spirit of service to the society, and you have got the free time which you can use in a very useful way, and you are liking what you do. It's not like out of necessity you are doing your duty. You are liking, you are enjoying your duty, and you are enjoying physical health, dynamic and vibrant health, and you are also enjoying the vibrant mental health. So this is a holistic view of a success. So basic human values, satyam, that is truth. Satyameva jayate nandutam satyena pantha vitato devayanaha. Satyameveshwaro loke satyadhamah pratishthitam satyamulani sarvani satyannasti parampadam. This world is working, this world is moving only due to the truth. Unless we adhere to the truth, we are doing disservice to ourselves as well as to others also. That means we have to walk the path of truth, not only conversing truth or talking truth, but we have to tread the path of truth. Satya marga. Karuna, that means compassion. Maitri, that is friendliness to all living beings. And Sahanubhuti, being empathetic to others and having patience. So what will give happiness and fulfillment? So work saturated with love towards our fellow beings. You are doing your duty anyway. So add love to your duty, just like curd to your rice or this thing. So then it will this work will be transformed into service, and it will lead to fulfillment in your heart and happiness also. Time management. Stephen R. Covey. So there is one quadrant. So four blocks are there. Important, urgent, important, not urgent, unimportant, urgent, unimportant, not urgent. We have to minimize the unimportant, not urgent things. Unimportant, urgent things also we have to minimize. So important, urgent, and important, not urgent, we have to list out and concentrate on them on a day-to-day basis. Okay. So sharpen your saw. This is also from Stephen R. Covey, 7 Habits of Highly Effective People. Staying up to date. If we do not up to date ourselves, then the world will move forward and leaving us behind. So we will be obsolete. So sharpen your saw is extremely important. And quest for excellence. So whatever we do, we should excel. We need not compare even for others with others. We can compare with ourselves. Yesterday I was, today I am how I am. Yesterday what I have done, can I do it in a better way now? That's why George Bernard Shaw says, if I am required to clean up a street, I want to be the best sweeper. I want to clean it in the best way. So that's what he says. So you take the initiative. That's the be proactive. That is the first principle of Stephen R. Covey in his 7 Habits of Highly Effective People. Trust other people. If you don't trust them, they won't trust you. So taking care of yourself, you have to trust them. You have to mentor them. You have to infuse them, instill them confidence in them, and then you have to own your municipality, own your organization as your own, and learn from others and share and network and lead. That will give you the capacity to lead. And then you have a goal, have a personal goal, have a professional goal, have a financial goal, have a family goal, and involve others. Work like a team. Together, everyone achieves more. Even for your personal purposes also, make your family members a team. Similarly, in a profession, make your colleagues in a team. Work with them. Each will contribute to the maximum. Then the leader also contributes, and leader also contributes, and then it will lead to success. So finally, what is the purpose of life? So in Japan, there is something like ikigai. That is the purpose. What is the purpose of life? So what do you love? So do you love your profession? Do you love your family? Do you love your fellow beings? What is my mission in life? What the world needs? What does the world need? What I can give to the world? You have got your career. So you can combine, you can synchronize your career to the world needs, what the world needs. So you should have a vocation, something like your regular employment, or even your music, dance, creative activities, some drawings, etc. Arts type, so specific types, and what I can be paid for. So I am paid for something, and let me go the extra way, go the extra line, extra length to contribute to my contribute to my organization, to my society, like that, and to your profession. What I am good at. So what I am good at, you have to improve it and contribute. And what is your passion? So your passion. So you combine your passion, your love, your what the world needs, and what you are good at. So then you will be purposeful in life. So why should you love your fellow beings, our fellow beings? There is a Stanford University study which is conducted from 1992 to 2002, which found that 1,000 out of 1,056 people from different continents, the DNA sequences of all the people, almost 99.9% of them, are identical. This study has been corroborated or supported by another 1,000 genome study in 2010. So what is our oneness behind all this diversity? I am Kondal Rao, Mr. Vishwakarma is there, like that, different people. But although we seem different, we are all one, irrespective of language or religion or region or caste. We are all one. We are all constituted of the same genetic predominantly. So our genes are transmitted from African ancestors 50,000 years ago. So even the genomes of humans and chimpanzees, we share 98.8% identical. Frogs and we share 70% identical. Similarly, lizards and ourselves, we share 60% identical. So then, what is the question that comes? Are we connected? So that's what all creation is in the Buddha. That's why I call you, my dear brothers and sisters, truly, scientifically, and philosophically. Then what is the definition of my family? So, Vasudhaiva Kutumbakam. So our great people in the Upanishads we say Vasudhaiva Kutumbakam. So the entire family, irrespective of our differences, we are all one. Religion, region, etc. So my dear friends, the floor is open for your questions. I am done. Any questions, please? I invite you to ask questions. My dear brothers and sisters, please feel free to clarify your any doubts or any issues. I request the organizers to unmute all people and let them ask.
Thank you so much, sir, for the wonderful presentation and explaining the topic in a simplifying way. Now, I request everyone to unmute themselves and ask questions. You can also type your questions in the chat box.
Yes, you can also type. So, do you want to make a difference to your fellow beings? That is the question before us, before all of us.
Once
So, this is what the
again,
Buddha
I
says.
request everyone to unmute themselves and ask questions.
Please.
Uh, so,
Yeah.
so Rao sir, amazing presentation. You're an amazing orator, and you're so humble, and you've touched such a deep topic with so much ease and level of understanding with your exposure. Highly in depth and really motivated by your talk today, sir. Amazing speech. Sir, what are the practical methods if we do bore wells across the entire property boundary? Would that help in increasing the water table around plain bore wells? What is the correct methodology of recharging the water?
So, recharging of the wells can be done, particularly the rainwater harvesting. Either it may be through rooftop rainwater harvesting or through our open areas harvesting. Open areas may be located in a school, in the campus of a school or a college or an institution, or even in an industrial area also. We can have open areas which will contribute to rainwater, surface water runoff, which can be collected in a lower contour, and then they can be used for
So
recharging the
that,
groundwater.
sir, that is a
And also you
little,
can have
yeah.
small check dams, etc., like
Right.
that.
Sir, so my question is a little different. It is very difficult for us to, allocate space or, a space for this. So if on my compound wall of any building, if I drill 4-inch or 6-inch wells, means like a bore well, if we dig down maybe about 200 feet, and whenever there is rainfall water passing through that in the bottom of the gutter or the storm water gutter, will that help recharge the water?
Definitely it will help.
So just purely drilling a 4-inch hole to a 200 feet below, whenever the stormwater drain starts working. Also, why doesn't the government actually have a plan that all stormwater drains must have bores which go 150 feet? Why don't they do it? Because at least during monsoon there'll be a lot of water that will go through the table and increase the table. But I don't see any regulation which says that every stormwater bottom should have a weep hole kind of a thing which goes down and recharges.
Yes, your point is very good. Actually, in the open areas also, we can have rainwater harvesting structures, which will lead to, after some filtration, you can lead the pipes to the bore well, what you are saying, so that the groundwater table can be enhanced. Definitely, it is
So
possible, and
that's
government should
where my
also go towards that one.
that
That's
is
a
my
good point.
second question, sir. So if I drill 150 feet deep hole, and I just leave the storm water there. Is that a correct way of treating it, or do I need to fill that well with gravel and sand for filtration? Because I'm not using primary filter, I'm just using the rainwater which will go down directly.
You
Does
can
it
use a
help?
primary filter. You can use a
I
primary filter so that the silt and etc. can does not enter the
does not enter the
uh,
picture. Okay.
uh, bore.
Right, right, right.
Better to use a primary filter.
Okay, perfect, sir. Understood, understood.
And you, as you said, the stormwater drain also some water, water percolation
Right,
structure. So there, as you have mentioned, say 15 meters, 20 meters intervals,
oh,
and also the water quality also can be enhanced
right,
in the drains. Yes, your point is very good.
right. ठीक है sir. Thank you so much, sir. I'm deeply, deeply motivated by your presentation today. It was an honor listening to you, sir, end to end. Amazing. And you're not only a good orator, but you've got an excellent voice. The song that you sung was amazing, sir. So thank you for enlightening all of us. I think there is a question in the chat box
Sure,
from.
sure, sure. I will see the question.
Yeah. Thank you, sir. Appreciate.
Role of plumbing in green building. Yes, definitely. You can have, I think, who has asked Techno LJ8K. Okay. So you have got plumbing systems. You can go for separate plumbing. For example, for gray water, separate plumbing system. For black water, separate plumbing system. So that you can treat the gray water separately, and you can pump it, and you can pump it to you can pump it to the overhead tank after treatment and disinfection, and use it for downstream purposes. You can use it for floor cleaning or car cleaning or your gardening, etc. And you can have a different pipeline for this thing for black water. Similarly, even for water also, for that matter, I think we have to think seriously whether we should have a dual water supply system. We can have different separate pipeline for drinking water and separate pipeline for normal water, normal household water. So that is also very important, because even other household water, water for other household purposes also, we are treating equal to the drinking water. How sustainable it is? We are spending so much of money, isn't it? So dual pumping system will enable sustainable use of water. Definitely, it will to contribute to better water quality, both inside, reuse, recycling, and also for external water quality contribution. Also, it will be definitely. It's a good thing. This is how we can do.
Hello?
Hello. Yes, please. Yes, please.
Hello?
Hello. Please.
నేను మాట్లాడొచ్చండి. నా పేరు పార్థసారథి.
నమస్కారం అండి. మాట్లాడండి, చెప్పండి.
ఇప్పుడు ఇన్ని వాటర్ స్కేర్సిటీ రాబోతోంది. నెక్స్ట్ ఫ్యూ ఇయర్స్ లో చాలా వీఆర్ గోయింగ్ టు ఫేస్ వాటర్ ప్రాబ్లమ్స్ అని మీరు పరిచయం చేయడం జరిగింది. అయితే ఇప్పుడు జనాభా పెరుగుదల విపరీతంగా పెరుగుతోంది. దాని మూలంగా ఏంటంటే కన్జంప్షన్ పెరుగుతోంది. దాని మూలంగా ఏంటంటే షార్టేజ్ వస్తోంది మనకి.
ఓకే.
So to say, the world input is less and the consumption is more. So we have to also concentrate on the population stabilization. So, for example, if our country is right now is able to satisfy the needs of nearly 140 crores of people, in order to stabilize the water supply and other things and augment the water.
I understood your point. I'll respond.
We have to control this 140 crores population also. That's what I meant to say.
I got your point. Let us discuss. So, true. It is true that population growth was there, but now the population growth in our country has stabilized. The 2.1 2.1, that is the per lady, the productivity of 2.1 is the replacement production. Whereas in our country, the productivity per person per lady is 2 only. So we have already reached the stability of population. By 2050 year, our population will be stabilized at about 150 to about 160 crores. So there already the number of the birth rate has come down, and the health facilities are improving, and the family planning initiatives which were taken earlier, they have borne fruit. So that's why we have reached a replacement situation, which has stopped now. I think you got the point. 2.1 is the fertility rate required for minimum fertility rate required for replacement. That is already reached in our country. So that is not a problem now, but the issue is environmental sustainability and protection of water bodies from pollution, from misuse, from wastage. So this is the main issue before us.
Thank you.
Thank you very much.
So
what are
there
the
is
common?
a question in the chat box.
Yes, please.
What are the common water management
Okay.
problems in urban areas?
Okay. So generally, what we are seeing, one is water contamination. So water contamination is being done through industries, through agricultural wastewater, through domestic wastewater. The second way is the sewage pipelines, that is sewerage network, is also contributing to cross pollution of the water pipelines. And acid rain, as a result of carbon emissions, as the rain is containing acids also. It is polluting the water bodies, both rivers as well as oceans also. So another thing is the stormwater is also, which when untreated, when improperly managed, that is also contributing to water pollution. And solid waste management dump sites. The water bodies which are nearer to solid waste management dump sites, they are also being contaminated due to underground pollution of the leachate and its percolation into the ground. It is polluting the wells as well as rivers or canals or other water bodies. So these are the contributing factors to water management. As far as the river water pollution is concerned, particularly the Ganga River, the Yamuna River, the Musi River in Hyderabad, the Kuam River in Telangana, and the Kshipra River in Madhya Pradesh, all these things are being contaminated due to excessive human interventions. For example, the Himalayas are contributing to the Himani Nada. That means the glaciers. The glaciers are due to the carbon emissions. The glaciers are melting, and our constructions like dams, like bridges, etc., or industries, are excessive development, which is not supported by the Himalayan geology. The geology of the Himalayas is very, very fragile. It is highly earthquake prone, and it is highly unstable slopes. So it is contributing to unstable slopes are contributing to landslides, heavy landslides, frequent landslides, and the pollution is also contributing to downstream pollution and reduction of water quantity as well as pollution of the water bodies, which is polluting the Ganga, Yamuna, and other Gomati, etc. rivers. So this is how our water bodies are being managed. As we have discussed, almost 311 rivers out of 605 rivers are highly polluted. It is borne by the CPCB studies itself. So, common water management problems. These are common problems. And we are polluting the lake due to urbanization. What we are doing, we are encroaching upon the lakes. We are filling the lakes with all sorts of solid waste, rubbish, etc. and we are reducing their area, water quantity, etc., or completely filling them. So what is happening? It is not contributing to biodiversity or contributing to the groundwater levels, groundwater recharges, etc. So we are that means we are not getting enough groundwater. And whatever groundwater is available, small groundwater, it is being extracted heavily. So groundwater extraction is becoming unsustainable. So this is how we are. These are the common problems of water management, which can be addressed by proper proper conservation of water, and groundwater recharging, rainwater recycling, rainwater recharging, rainwater harvesting. So, water treated wastewater, that is effluent, and grey water recycling at household level and at domestic level, so at industrial levels. So these are the simple procedures. These things we can utilize for better management of water system or water resources. And stormwater, sustainable stormwater management methods, what we have discussed. Sustainable urban drainage systems, etc. Blue and green infrastructure like that. Any other? I think I have answered. Are you satisfied with my answer?
So now I see there is no more questions anymore. So we move
Okay.
towards closing session. Before that, I would like to convey a message to you on behalf of Dr. Sundar Kataria, CEO of ICS. He was attending the session from the beginning. However, due to travel, he faced some technical issues. On his behalf, I sincerely thank you for such a knowledgeable and informative session. We would also like to thank Mr. Vijay Vishwakarma sir for recommending Mr. Kundalarao Gonugudla sir for us for this session.
Thank you very much. I thank the ICS Technologies and all the participants and the organizers and all the participants and others who have patiently listened and asked questions. I hope I have answered the questions appropriately. I thank once again all of you for the opportunity given to me.
ICS is pleased to provide you all its research and development, integrated management system, QMS, EMS, OHSAS, excellence in education management, ISO made easy in Gujarati, Marathi, Telugu, Hindi. For reading any of the above books, please contact Mr. Sushma Kindalkar. Feedback form, please register on www.sadgunsang.org and go in your login and give feedback. Thank you for being a part of the Sadgun Song.
Thank you very much, all of you.
Thank you so much, sir, once again.